Alright, so here's a bit of an introductory video on the Onan generator project. So we got this generator for two reasons. One is we want to use it as our three-phase or heavy amperage power supply for this job we have in Missouri, where we might not have access to either three-phase power or the sufficient amperage to power our big planer with the dust collector, compressor, there's quite a bit of tools that may run at once. So the second reason is it'll end up being the backup generator at the main compound as a either three-phase supply and emergency backup if the power goes out. And at first we thought it was going to run on, it was originally set up for natural gas. But when I called this great company, Onan Supply, and talked to this awesome guy, Rob, there, and he walked me through some stuff, and it actually is already set up to run on propane. So propane, while for a portable generator, is more expensive and a little more difficult to deal with, for a standby generator for emergency usage, it's great because you can have a tank of propane sitting there stable forever and it'll be completely fine. And we already have a large propane tank that we might repurpose at the main compound. And then for the portable usage, we're just going to add some like RV propane tanks and get this rigged up for that. So why don't we do a walkthrough on each side, and I'll show you all the different features and stuff. All right, so it's an Onan model 35EK. According to the serial number, it was manufactured in 1995. It's rated at 35 kilowatts, single phase or three phase, and you can tap the transformer or the generator head for all the different three phase voltages. So we'll probably tap it for 240 three phase with a center tap, and that'll give us, if we're running it at three phase, it'll give us the 120, 240 plus the three phase 240, which all our machines should be able to handle. Here's the main disconnect box. I don't know what, they must have been running it as a single phase unit because it just has a 2-pole 100 amp breaker in here. It looks like when they disconnected, they just snipped everything. Not ideal. And this is the big center tap for the neutral leg. So they were probably running, 240 or something single phase. So we'll have to figure out, get a 3-pole disconnect or a 3-pole breaker. These are kind of expensive, but we might be able to salvage just a fuse disconnect for this and run that to our panel. It's got a Ford 6-cylinder. I believe this is a 300 cubic inch gasoline engine. This is like, I believe this engine is in every 6-cylinder Ford, like the standard 6-cylinder Ford. That's what this engine is. So it's like easy to get parts. It looks pretty clean. There's a little bit of oil and grime everywhere. Looks like they did a filter change December 20 of 2020, and I think that means the hour meter is probably accurate. It's pretty low hours, so I don't know why we didn't pay a whole lot for this. But I think it's probably because everybody's looking for the diesel backup generators, or the diesel like site generators, and not the propane or natural gas generator. The battery was dead, so we got a battery. And coming around here, radiator. Check that in a minute. And here's the fuel side of everything. So I guess this must have been plumbed to quite a large surface because this is a pretty big pipe. Got a inch pipe coming in. This is the solenoid that controls the fuel. Then this is the secondary regulator, which is a IMCO model 52, which connects to this IMCO CA125 propane carburetor, or propane air mixer thing. And then this is the throttle linkage. Yeah, so I talked to this guy, and he was great. I mean, he basically knew the numbers before I even told him just by describing the stuff. And he said it should run. We're going to hook up a barbecue grill gas tank, and it should get the engine started. And then that way we can test it before we invest in larger propane tanks. Here's literally, there's 2 rat's nests in here, a figurative one and a literal one. We got to clean that out. All of these are the taps, so that's why it says T10, T5, etc. Right now it's set up for, I believe it's wired for parallel Y. And we're thinking we might change it to Series Delta, because that'll get us our 122/40 3-phase. And they, again, they just clipped all the wires. So we're gonna have to tape these up when we test it, so it's not just blasting voltage all over the place. But it's nice they give you all the different taps on this panel. One thing that I do not know what it is, I have a theory. There's this whole apparatus down here, and what's happening is looks like there's coolant pipes from the engine that go to this thing that has a pressure switch, electricity, and I think this is an oil pressure line. If I had to guess, when there's oil pressure from the engine, it turns on this thing which heats up the coolant and makes it warm up faster. If anybody knows, it says down here Kim Hot Start, which is sort of why I thought about that. If anybody knows what that is, let me know. All right, and here's the sort of the control center. We have the AC volts, AC amps, RPM, battery voltage, temperature, oil, pressure. This I got to read the manual about. It appears that you can change the taps or something. I'm guessing this might be what switches between those different modes. 254 hours, so that's a low hour unit. And it has all these alarms. I mean, this looks really nice. Like, it even has a little lamp. So I don't even see a start button now. That's something to run, stop. I'll have to figure out how to start this beast. Yeah, and the whole thing, which I've seen them outside of this, the whole thing comes with this cool housing so it can sit outside.
About to power wash this thing?
Yeah. We cleaned up the generator and it's looking very nice. This engine is super clean. I couldn't even see this label in the throttle linkage. Also very clean. I noticed that there's no vacuum line to the vacuum advance. I'm not sure how necessary that is. This looks like an oil pressure sender. I don't know what's going on here, but this wire is cut. There's also maybe a temperature sensor or something that's cut. We'll deal with that. The next thing we're going to do here is swap out this union for a new union, a bushing, and a flare fitting so we can hook up this hose to the temporary gas supply. And we taped up all these wires so we should be able to start the engine and see if it runs. Yeah.
No. Fuck.
What is it?
I thought they had the wrong fitting in the goddamn drawer. Well, let's check for leaks.
Oh yeah, this would bubble if it leaked. Looks clean to me.
Yeah.
Checking the oil. Could use a little oil. So when I looked in the radiator, there's a big filler neck. I didn't see fluid, but this strange thing seems to indicate that it has fluid in it. So I'm gonna probably crack the petcock just to be sure. There's some fluid coming out. Well, I'd rather it overflow a little bit and then not have coolant. We'll check it once we get it running. All right, we checked the oil, we checked the fluid, we got the fuel on, we put a battery on, and as soon as I put the battery on, this switch off thing is blinking. So I actually am gonna pause and read the manual because I don't want to destroy this thing. It's in stop mode, and if I put it to run, it should automatically try to start the engine, which is cool. It has like all the high-tech stuff going on here. So I'm gonna move the camera and try to start it. All right, let's see if it runs. Interesting. Interesting. What does that mean? It starts up and then stops the cranking, but it doesn't continue to start. All right, let's try it again. It wants to run.
Yeah. Jenny wants to go. Sounded like it was on for longer that time.
Whoa.
What?
Beautiful. Beautiful.
Now we're talking.
This must be for some accessory. That looks pretty nice.
Bro.
That does not look like anything got broken in here. This is a satisfying panel.
No, this is a very satisfying panel.
like, wouldn't it be great if you got like a thing where they were just like, yeah, we were taking it out of service because we wanted a bigger one.
Right.
Or, oh, because the fucking cylinder exploded.
Yeah.
Like, yeah, you know, like, it would be great to know what you were getting into.
Mm-hmm.
But I guess if they're trying to get the most money, but I mean, it would suck if we tried to, you know, like, it would be time consuming and expensive if we did all this work
On site.
on site. It's probably this, right? Some gross shit in here. That is an insane generator head. Let's try again. This is gonna be cool when it turns. Interesting. All right, so I think we found something potentially that could be the problem here. There's a couple wires that were cut. It looks like one of them's an oil pressure sender. I don't know why there's a T and a cross. There's 3 oil pressure senders here. And there's a couple cut wires. And I thought this engine was just going to start up, but since this is such a smart machine, I think it's looking for oil pressure when it cranks, and it will just shut the engine down if it doesn't see any. So I think I have to remove this board, and behind here I should be able to figure out which wires were cut, and then I'll figure out which goes to which sensor. Oh man. I spent the whole day troubleshooting this thing, and it was not very interesting. And basically, I've come to the conclusion there's insufficient fuel flow to keep the engine running. And I arrived at that conclusion because if I bypass the control board by basically turning on the ignition and fuel solenoid and then run the starter, I get it to turn over and then it just keeps cranking, which leads me to believe that one turnover is the sort of a collection of fuel that gets in the regulator, and it just can't flow enough fuel to keep it going, because I did hardwire the starter, and as I blasted a little bit of starting fluid in the top of the mixer, it would turn over again, So I think I need to figure out how I can get more fuel flow, probably larger tanks and the right on-tank regulator. Try not to spend too much money on this. Everything seems like it's working, but it'd be nice to figure that out before buying a bunch of propane tanks. Your Google reviews do not lie. You guys are. This is the place I've been looking for weeks now.
Well, thank you.
Like.
Yeah, we definitely pretty prideful about that, because that's really where today's at your whole presence.
It's impossible to find like people that know what they're talking about and do what they say.
I've been doing this my whole freaking life.
Yeah.
So. you pick up stuff every day. You know what I mean?
Yeah.
So I've learned so much about more than I want to know sometimes.
It's part of the fun for me. Like I could spend maybe twice as much on a generator that's like plug and play, but I
You're
like
learning
fixing old
along the
stuff.
process,
Yeah.
man, for sure. Oh, definitely.
So this is the T that joins the two tanks.
Yeah, this will join everything together. See, this will be the T, and then this will go like this.
Oh, that's the weird CAA
Exactly.
whatever.
It's called a POL fitting, is what that is.
Okay.
And that's a 7/8 left-hand fitting. So that tightens up, and that's the same as what's in the tank. It's a connection that screws onto the bottle, look like this, plastic hand wheel. That's exactly what it is.
Ah.
This piece, not the tank itself.
Ah.
This piece right here has an excessive flow check built into it.
Yeah, I went camping with my buddy one time, and it was so funny because it was so cold, and we're like, all we wanted to do was set up the tent and have a couple beers. The beers froze, so we turned on the camp stove to heat up the beers, but then the tank wouldn't flow so we had the tank between our legs trying to heat up the beers.
Yep. Been there before too.
Yeah. Oh, I see. All right, it's been a couple days. I had some time to do some research, post some messages on forums, and yeah, it seems like it was just not going to start on that little propane tank. So I got what will probably be the more permanent setup. Hopefully it is not a complete waste of money. 2 100-pound propane tanks, and this regulator setup, which is going to put these tanks in parallel. Both tanks are going to feed this regulator, and this regulator can support the flow that this engine would need under load. I also believe there's a check valve. I was told there's a check valve that if this engine's drawing more than that barbecue grill could take, it would just shut it off for safety. So that's probably what was happening, because it started to pull enough to kind of turn it over once or twice, and then it was pulling too much, so it cut the fuel off, and that killed the engine. So we'll get this set up and replumbed. I'm probably just going to leave things as they are, and then if this runs and everything's working, we'll build mounts for the tanks and get it, nice and I hope this works this time. Hopefully we have enough propane flow. It's running. That's awesome. Yes! Okay, awesome. So that was the problem. All right, this is what we got. I did a bunch of research, and I'll walk you through what's going on here. So this is the connection we have currently. Parallel Y. It's Y. And so that gives us a L0, L1, L2, L3. L0 is the center tap, basically your neutral. And then the L's are the three-phase connections. Any connection between L1 and L0 will give you 120 volts. Any connection between L1, L2, L3, here to here, here to here, here to here, is going to give you 208 volts. And so I'm hoping to eventually rewire it to series delta, which is sort of the older three-phase, and that gives me the 240 volt three-phase as well as a 240 volt single phase going obviously between any of the L's, and the 120 volt to the center tap. So that sort of gives me my normal single phase power plus the ability to run 243 phase stuff. But right now it's wired like this. And so what I did is I hooked up this electric heater, which is in a rather dangerous configuration, to two of the three-phase legs. So this is definitely going to be unbalanced, but I'm not going to run it for that long. I'm hoping that you kind of want to have your loads balanced across the different phases. But what I'm hoping is that what happens is when I turn on this switch and it engages the startup relay, you know, after a couple minutes of warming up, it'll turn the fan on. So as soon as I turn that switch, basically, we should see an increase in load, which is I got the ammeter here to measure the current. And we can also measure the current and voltage on the meters here. And so we should see the engine speed up to compensate for that load. And hopefully nothing explodes. So that test worked out pretty well. We saw it got the current up on the ammeter. It was drawing current. Yeah, I didn't even notice the engine load. It didn't even notice that. So I'm curious what kind of load we're going to need to really make it work. But I guess with that, I'm confident that it makes power and that it's worth putting a little bit of work in to get this portable. So one thing we obviously need to do is we can't be running the generator like this willy-nilly. We gotta run the taps through here, and ideally this is going to be a three-pole three-phase breaker, not this single pole, and that gives us a main breaker, and then we can feed our disconnect or our three-phase panel for temp usage. Put some outlets there so we can just plug stuff in. I have some salvaged electrical equipment in mind for that. I don't know. I might have to try to order one of these or swap in a feasible disconnect. We'll get the battery mounted, and then over here we got to figure out how to mount the generator to the physical trailer. There's got to be some plates here or something. We can make some straps. That way we can get these load binders off, and then I'm thinking we'll put a plate here and post that we can mount the tanks on and have straps to hold them on and something to hold the regulator still. And that'll be a nice power unit.